before. You said I guess the question I wanted to find out is that when the Murres come back to their nesting burrows, are they loyal to that burrow, and so you can catch them again?
They are.
Okay.
Murres are really amazing. They will nest on a ledge no bigger than this podium, very narrow. They will return to the exact spot within. They nest in about this much space, and they will return year after year to that location. And they're if you spend time at a Murre colony doing behavioral observations, something you do as you're sitting in your blind is you make a map of the plot and you write, this is that rock and that's the cave, and this is Murre 2, 3, and 4 that live right there, and 5, 6, and 7 are on this part of the cliff. And if you look at that map next year, you'll know, oh, that's bird 3. He's back in his cave. Bird 7 is on that boulder. You can track them from year to year just by the position that they take up on the cliff. So that is important in retrieving some of those archival tracking devices that I think Ken was alluding to.
So in a given year on Trunk Island, let's say, where research is being done, I suspect it's being done each year, how many birds would you quote it, or how many you're going to go out and tag on them, or?
No, it depends how many tags we're allowed to buy.
Okay.
How much money we have for tags. But of course, through the university, you have research permits and animal care permits allowing you to catch a certain number. So you wouldn't be allowed to indiscriminately mark hundreds of birds or thousands. You know, there would be a reasonable limit. Also, there's probably critical mass at which you're finding out enough information from a certain number of birds. You can kind of extrapolate to what everybody else is doing, more or less. Okay, so let's get back to talking a little more about the Murres that I studied. So I'd like to move us into talking a bit about some of my research on tracking year-round habitat use for Murres specifically, so looking at the distribution. So my work sort of boils down to two basic questions. One was, where are Murres going in winter, or in the non-breeding season? I'm sorry, I'm going to use those terms interchangeably. Sometimes I say winter, and sometimes I mean non-breeding, but we're talking about the time that they're not at the colony. And from that information, I wanted to investigate what variation in risk might Murres encounter during that winter period. So, sorry to get all, I don't mean to go all academic on you or anything, but so this is the title of my thesis was Ecological Segregation of Murres during the non-breeding season in the Northwest Atlantic. And I just wanted to point out again, this was work done with Bill Montevecchi at Memorial University. So in studying this system, we want to think about ecological segregation in terms like this. So theory is telling us that competition for a finite resource, like food, has resulted in ecological segregation among species. And at colonies, seabirds, as I alluded to before, are what we call central place foragers. So this means, let's pretend this is a colony, and this is the foraging range of a seabird. When a seabird has to fly to get food and then come back within at least a day to feed its chick, there's a limit to how far it can go in a day. So we have this kind of foraging radius around a colony. And if you have a huge seabird colony with multiple species, we consider this to be kind of a restriction. So all these birds are restricted to foraging in a particular location around the colony. And so to avoid competition, we have trophic niches that are established between the different seabird types through competitive interactions and through ecological segregation.
Could you explain that term, trophic niche?
Yes. So a trophic niche is, so trophic, it just means the level of the food chain at which you're foraging. So if you're finding food at a low trophic level, that's something like a zooplankton or a euphosid. And if you're finding food at a high trophic level, up in the food chain, it's a larger fish, sort of progressively as up the food chain of fish. And if you want to pass fish, then you're getting up into sort of the consumers that you know, the big fish eats the little fish eats, that kind of a system. So a niche is the the spot on the food chain in which you're best at finding food. Does that make sense?
Mm-hmm.
Okay. So among species that are morphologically similar, so like the Murres, they have the same body shape, they have a similar shaped bill, they both dive and chase their prey in the water column. Segregation needs to happen through either differences in space or in time, so maybe one forages in the morning and one forages in the evening, and in sort of subtle tweaking of the diet. I want to give you an example. So when I say interspecific segregation, I mean between species. So in this case, we have the thick-billed murre and the razorbill. Let's imagine they're both breeding in a colony. This is their diving behavior. So just frequency of dives here, and on the x-axis is how deep they dive. So in this case, we have thick-billed murres diving at a whole range of depths, including up here at 50, 60, 70 meters in the water column. And razorbills are really only sampling the water column at a much narrower sort of number of scale of depth. So only up to 20 meters, really. So in this case, the segregation is happening in space, but it's not in space as we consider it sort of vertically. It's more horizontal space in the water column. So this is an example of segregation between species. Here's another example. So this is an example of 3 different species of gull, all breeding at the same colony and all foraging within a certain central place around the colony. In this case, we're looking at differences in diet. So again, getting back to the trophic niche. As you go upwards in the in the food chain, you become more enriched in nitrogen. So this is a measure of the position in the food chain at which you're feeding. Now you're all familiar with the term, you are what you eat. So this works for seabirds too. As they consume various levels of prey, the isotopic signature of the prey becomes internalized into the body tissues of the consumer. So let's say the more fish they eat, the higher up in the food chain they're going to get, the higher up in nitrogen, they're going to be enriched in nitrogen. The lower in the food chain they eat, the lower the nitrogen level is. So I just want to look just at the nitrogen scale. So let's look at this species, the triangle species of gull. They're foraging at a particular trophic level, and that separates out from this species of gull here, and that separates out from this species of gull here. So these are individuals, and that's a measure of their tissues. So this is segregation in diet among different gulls. Does that make sense? Okay. One more example. So now I'm looking at intraspecific. So this is all the same species, but it's between neighboring colonies. So here's a colony of gentoo penguins, foraging ranges, all on one side of that island, and the foraging ranges at the adjacent colony are completely separate at another side of the island. So this is another common pattern in a way that one single species will separate out and avoid competition. This is a great example. These are gannet colonies surrounding the UK. Each color represents individuals from that colony, and they're all foraging in really quite distinct areas around their own colony, really separating out. There's a little bit of overlap here and there. They're really separating out. We don't fully understand what the mechanisms are to prevent these neighboring colonies from overlapping at sea. That's a mystery still. I don't think, bird from colony A runs into bird from colony B and says, "You're not my kind, go away." So that part is really an intriguing mystery. Okay, so that was all breeding season stuff that I was telling you about. What happens in the non-breeding season? Birds are released from that central place. They can presumably range however far they want, depending on what species they are. In this case, this is a sooty shearwater migrating from the Falkland Islands to Newfoundland and back in the non-breeding season. Some research suggests that some seabirds will move from their colony into the wintering period and winter in very specific areas in different parts of the ocean. But the question for me that I find interesting is, so does this type of ecological segregation in time or space or diet happen during the non-breeding period as well? So this is what I want to look at for my study with Murres. So again, I'm just going to remind you, the thick-billed and the common murre have this circumpolar distribution. They're closely related. They're both pursuit divers, and there's a small difference in the trophic niche at which they're best at foraging. Common murres target a little bit more the forage fish. Thick-billed murres eat the same type of forage fish, but they can also consume a variety of zooplankton. So maybe a little bit of diet segregation there. So I wanted to identify and compare those winter movements and distribution of murres to look at niche separation through patterns of time, space, and diet, like I said. What happens in areas where there's greater spatial overlap? Is there differences in niche partitioning? And what are the patterns of migratory connectivity at population or at colony level? So what I mean by that is we have a bunch of different colonies, and the birds leave the colony for the winter. Migratory connectivity refers to the degree to which birds from one colony move to either the same wintering area as other colonies, or if they all mix up together. So the connectivity is how much they're mixing on the wintering ground. So the colonies that I was able to study birds from include Prince Leopold up here in the high Arctic, which I did not go to because I'm sure someone is going to ask me that. I didn't get to all of these colonies, but I had colleagues deploying and retrieving devices from these colonies. Prince Leopold Island in the high Arctic, the Minarets here in Davis Strait, 2 colonies near Hudson Bay, so we were kind of at an angle here, but this is Hudson Bay. 1 colony off the coast of Labrador at the Gannet Island, and colonies at Funk Island and Gull Island. So these ones up here in the dark blue are the thick-billed murre colonies. In the black are the common murre colonies, and at one spot I had 1 colony where the 2 species were co-occurring. They're breeding at the same, as I said before, on the same breeding ledges, basically. There's the thick-bill and there's the common. And I should be able to tell you whose chick that is. Someone else probably can in this room. That's one of their chicks are diabolically hard to tell apart. Okay, my method. So I basically trap the birds with this noose pole. This is a long pole. It's a telescopic bamboo pole. Very fun. It's got a noose at the end. You lower the noose over the head of the bird and pull. And that's how you catch the bird. We attach these geolocators. So this is a light sensing device. It works a little bit in a way that you would navigate at sea by the light level. It tells you latitude and longitude, basically, by global light level. We attached it, it's hard to see, but it's on a little band on the leg. We put it on, and then the next year I came back to this ledge and grabbed those birds off the ledge again to get it back. I also took tissue samples, so I took a little bit of blood. This is a blood card. We just take a bit of blood and we dot it on a kind of an absorbent paper, and there's my blood sample. I took a feather sample, just a little piece of a feather from all the birds as well. And the reason I took tissue samples was because I wanted to look at those trophic positions, so the nitrogen and carbon signatures that are incorporated into those tissues.
So you're saying feathers as tissues, or are you taking other tissues?
Nope, just feathers. Feathers as tissues, yes.
Okay.
Feathers and blood. I didn't take any toenails or anything. Some people do that sometimes. Okay, I want to show you what it looks like when you clean up the geolocator data and track it over time. This is going to be an example. It's going to go a little bit fast, so I want you to notice this is the time up here, 12th of August 2007, and it's going to be a little movie that shows you a track of the different color track will be different individual birds, and they're being tracked from Coast Island and their thick-bill Murres. So this is what it looks like. This is the data that's going to. So these are just birds squiggling around. You'll notice the resolution, the spatial resolution on the data is not super fine. It's not like a satellite tag. So again, each color is an individual bird. Okay, we're in July. Now we're in the next year, September. The birds are coming out of Hudson Bay, moving in the Labrador Strait, going back again in March and April. So that's kind of a mess, but it's kind of fun. So let's just look quickly. So there's one bird, this blue bird. I don't know if you noticed that. We'll play it again, but it came out, all the birds come out of Hudson Bay late November, early December, which was a bit of a surprise to us, actually. We thought they came out right away in September. One bird went up here off the west coast of Greenland, and it hung out there. And I'll play it again, but it does it twice. It does it in 2 consecutive years. Another bird hangs out here. These 2 birds are down here in the Labrador Current. One makes a little detour almost to the Scotia shelf before it goes back. I just want to play it again because I want you to notice the repeat years. So maybe watch the blue guy. So this is November, December, January, February, March and April, kind of make a jump. And now we're in the fall again of the next year. We're in October. There's that green guy going down here again, and the blue guy's going up there again. March and April, little squiggle, back again. So this is the kind of data that I was looking at with all of the tags that I retrieved.
Some of them cross over land?
No, that's a resolution issue with the geolocation.